Suppose that you have two vectors. We'll draw them in R2, but you could do this in any dimension. We're going to learn how to take one of these vectors and project it onto another. And what an orthogonal projection is this: completing the right triangle. So let's say we have a vector y and a vector u. Suppose we have two vectors like so. We're going to learn how to orthogonally project one of the vectors onto another. Orthogonal projection looks like this. We form a right triangle like so. Remember that two vectors are orthogonal if they hit each other at a right angle. And we'll see motivations and why we would want to do this soon enough. For now, let's just learn how to do it. So let's call this vector y and this vector u. And this vector, the one that created the right triangle, let's call that z. This side of the right triangle we'll call y hat. So y equals y hat plus z. And each of these vectors in this decomposition has some property. Y hat is a scalar multiple of u. And z is orthogonal to u. Taking this first, we have a formula that gives us this alpha. Y hat equals y dot u divided by u dot u. That's our alpha times u. And once we know y hat, we know z, because z equals y minus y hat. This here is the orthogonal projection of y onto u. This is the component of y orthogonal to u. Where does that come from? Well, for z equals y minus y hat to be orthogonal to u, 0 has to be y minus y hat dot to u. By definition, for two vectors to be orthogonal, their dot product has to be 0. Y hat is alpha times u for some alpha. So y minus alpha u dot to u. The dot product distributes over this subtraction, and now it's just a matter of solving for alpha.